Okay, guys, so this is the question which was written in June 2022. This is KZN. Question number 6 on trigonometry. As you can see, 16 marks the whole of this question that we are seeing here. So we are going to quickly rush through our question so that we'll figure out how we're supposed to attempt or to answer these questions. 6.1, we are given, prove that. Okay, it's a prove, like you are given a trigonometric identity there that you are given to prove. This, what we have on the left hand side, is equal to a 1. Okay, so whenever you are to prove, you are dealing with trigonometry, there you want to prove a certain part that you're given, just try to analyze what you are given. All right, let us see what we are given in this case. 6.1, we are given, this is 1 minus sine squared theta. All right, in the bracket, then we are given into the product, that is 1 plus tan squared. So this is tan squared theta, which is equal to 1. Let us consider to say that from our identities, remember, we do understand that there are identities that we can use, okay, which we can work from. First of all, they are from our Pythagoras, which is the Pythagorean identities or the square identities. We understand that the sine squared of theta, when added to the cos squared of theta, is supposed to give us a 1. Okay? The reason that we are to bring out these identities, because if we are to check their brackets there, and in whatever case that you need, you have to expand. And in expanding there, you are creating more problems, actually. We also do understand that 1 plus the tan squared of theta is supposed to be equivalent to the sec squared of theta. If we are referring in terms of theta, if we are referring in terms of x, is fine. So let us take this now into consideration to say that if we are to take the left-hand side, and let's say want to work from the left-hand side, because that is the most complicated part that we have. From the left-hand side, we are given a bracket of 1 minus sine squared theta into the bracket of 1 plus a tan squared theta. This is our left-hand side of the equation. All right. I have a 1 minus sine squared, but here I have got a sine squared plus a cos squared, which is equivalent to a 1. So if we are to figure out what made us to have this 1 minus sine squared, it is just because I transposed the sine squared this side so that it becomes a positive. So the moment I transpose a sine squared on the right-hand side, what is going to happen? It becomes a minus, meaning to say you'll be left on the left-hand side of this side of the equation with a cos squared. So meaning to say, in actual sense, from this, we can tell that a cos squared of theta is going to be equal to 1 minus a sine squared of theta. So if that is the case, at least let us work with a single identity than to work something that we are adding or subtracting. At least let us try to work with a single identity. So in place of a 1 minus sine squared, I can substitute the equivalent, which is a cos squared. At least that's a single identity. Times, we do the same thing on this. We are adding there another part that you're adding. So at least try to work with a single identity. What is it that is equivalent to 1 plus tan squared? It is equivalent to a sec, which is sec squared theta. So as if we are simplifying, as if we are complicating this, no, we are not. I want you to see something. Remember that from the reciprocal of our ratios, okay, we understand that 1 over a cos of theta, or if it is cos x, whatever that you have, it is equal to the sec. Okay, 1 over cos, it's sec. If it is 1 over a sine of theta, it is equal to a cos sec theta. Take note, cos changes to s, which is sec, sine, cosec. All right, so there is a sec squared theta, meaning to say if it is a squared, if I square this is also supposed to be a cos squared. So I can replace a sec squared with a 1 over cos squared, since here I'm already having a cos squared. So a cos squared in the first place, this one, times, if we are to multiply with this sec squared, the equivalent of a sec squared will be 1 over a cos squared. So this will be 1 over a cos squared theta. So this is just same as over 1. You are multiplying, remember, from your fractions. If these two are the same, the numerator and the denominator, we can cancel this. So that will be 1 over 1. And at the end, everything is going to give us a 1, which is exactly what we have on the right-hand side. So meaning to say at the end, our left-hand side is equal to the right-hand side. So this is the idea of the proof. You have to work from one side and try to apply your identities. Yeah, that is the most important part that you need. Try to apply your identities. Make sure that you have your identities. You know your identities. You know the simplification, how to use your identities. That is the most important part that you are going to have. Anyways, let us check the other part of our question, which is on 6.2. 6.2, you're given solve this for x. Okay, this part solve for x, where x is an element taken from minus 90 degrees up to positive 90 degrees. It is very, very important that you do have, or you do know, the interval that you are going to work with. All right, so this is an equation now. This is no longer an identity, this one. Solve, it is to find the values of x. So we are given that the sine of 2x plus 30 degrees in this case is equal to minus 0.4, where x is supposed to be an element, is supposed to be numbers taken from minus 90 degrees up to positive 90 within this interval. So as long you are to solve a trigonometric equation, the first thing that you're supposed to think of is what you call the reference angle. Provided that I am given a single trigonometric ratio here. All right, like what I'm given is your sine of x is it's just a single part that we have. So we can consider the part of the reference angle. And as we are considering the part of the reference angle, ignore this negative that you're given there. All right, if I was given something like this, let's say I was given the sine of x is equal to 0.4. The reference angle is simply arcsine of the 0.4 that I'm having here. Then the solutions will be related from x. So in this case, you are supposed to be careful that we are no longer considering this is just x. This is 2x plus 30 degrees. 2x plus 30 degrees. So I would encourage you on this type of equation to, yes, determine your solutions at the end, but try to use the general solution concept. That one can help you to determine your solution in an easier way. I'm going to explain that part. All right, so like I said, this is a single trig. It's a single trig that you're given. There's nothing that is there. If there was a 2, first thing is to get rid of that 2. You divide by the 2, any number that is there, but we do not have that. So if you do not have that, simply find the reference angle. So the reference angle, it is equal to the arc of this trig that you have here. It's sine, so it is going to be arc sine on the other hand of 0.4. You ignore the negative that you have. The negative, it represents the quadrant where the sine is situated, where the sine is located. So don't consider that negative there. All right, so that's you're going to have your reference angle in this case, which is the arcsine of 0.4. So like I say, do not consider the negative part. All right. So on your calculator, to 2 decimal places, just gonna shift, set up your calculator. You're gonna fix it to 2 decimal places. All right. So that is arcsine 0.4. So arcsine 0.4 is shift sign. All right, so this is 23.58 degrees. So that's 23.58 degrees. So the reference angle now, what it does is it is found in each and every quadrant. Each and every quadrant, it is having this reference angle. In the first quadrant, remember I said there is a reference angle, there is a reference angle. In each and every quadrant that you have, there is a reference angle. So what you need is to now consider to say, like I said before, if let's say we know that here, there's a negative that we are talking about. So where sine is a negative from the cast concept or from the all students take calculus, still one and the same thing, you're going to see that the sign being a negative here, being a negative, it is because it is in which quadrant? The third quadrant. Here, tan is a positive, so meaning to say sine is going to carry a negative. In this quadrant, cos is a positive, meaning to say sine is going to carry a negative. So these are the 2 quadrants that we are going to have at the end, with our sign being a negative. We are going to take our answer in the third and in the fourth quadrant, where sine is a negative. But this is the idea then. If you were to relate basically like the way that we are used to, we are used not to have this. We are just used to have something like this. The sine of x is equal to minus 0.4. So if it was like this, you were going to write your solutions. Let's say you are to now give the general solution where you're going to have your exact solution. You are going to take your x, because take note, negative values are also there. Here, this one is from 0 to 90 degrees. Negative angles are not here. So that's why I'm saying you have to prefer for that general solution. You are going to have your solution like this. X is equal to, you consider to say where that sign is a negative. Okay, where is it a negative? In the third quadrant. And how do you write the angle? Given a reference angle in the third quadrant, this is given as 180 degrees plus the reference angle. You add the reference angle. So it's 180 degrees plus the reference angle. Then remember, for a sine and a cos, because of their period, which is 360 degrees, it was going to be 360 degrees times what? Times k, where k is an element of the integers. This is what we're used to, because there is an axe here. But now it's no longer like that. Even if you move to fourth quadrant, it's going to be 360 degrees minus the reference angle, this and that. We're going to talk about that. I want to talk about this part here, the part of x. So in this situation that we are having, be careful and mindful that it's no longer just x. It's 2x plus 30. So you take it the way that it is, but maintaining the part of the general solution concept. Meaning to say, this is not just x, just like the way that it was sine x. That is why we're saying x is equal to. Now it is going to be 2x plus 30 is equal to this. 2x plus 30. You take it as the way that you're given there. Then you calculate for x. You calculate or you solve for x. All right. So let us start. Like I said, our solutions are going to be in the third and in the fourth quadrant. So we're going to start with the general solutions. All right. So in the third quadrant, our x, which is not just x this time, it is 2x plus 30. So 2x plus 30 degrees was supposed to be equal to, how do you take the solution? In the third quadrant, it's 180 plus the reference angle. So it was going to be 180 degrees plus the reference angle, 23.58 degrees. This is where our sign is a negative. It is positive in the first and the second. So we don't consider that, because we need where it is a negative. That is where the negative plays a role. That is where it plays a role. So that's why we did not consider the negative there. All right. So don't forget to add 360 degrees times what? Times k, where k is representing all the integers that you can have. So this is the part that you are going to have if you are working from the third quadrant. But this is not where our solution is, only where the sign is negative. The sign is also negative in the fourth quadrant. And in the fourth quadrant, whatever solution that you're going to have, it is going to be 360 degrees. You subtract the reference because you're moving from this point up to this point. So you subtract this gap, this one, the reference angle. So it's 360 degrees minus the reference angle. So it was supposed to be x is equal to, but we are no longer having the x concept because of these 2x plus 30. So we are going to take it like that. So in the fourth quadrant, also our sign is negative. So therefore 2x plus 30 degrees was going to be equal to, in the fourth quadrant, how do you take your solution? 360 minus the reference angle. So it was going to be 360 minus the reference angle. Remember our reference angle 23.58 degrees plus 360 degrees times what? Times k, where k is an element of all the integers. All integers. So that is from these two, that is where we are going to work out our solutions now, from these two. The one for the fourth, the one for the third. So let us start with the third quadrant and we move on to the fourth after that. So meaning to say, we are supposed to solve for x. This is not x. This is 2x is equal to. We need x. So what are we going to do? All right, let us just try to combine this part here and see what you're going to have. So this is 2x plus 30 degrees, which is equal to 180. We add the 23.58. This is going to be 203.58 degrees plus 360 degrees times k. All right, so this is what you're going to do. This is an angle and this is also an angle. So you can subtract that. Here there's a k, so these are unlike terms. So the angle, you subtract it to 208.58. So it means 2x is equal to 203.58. You subtract 30 degrees. So if you subtract 30, you are going to obtain 173.58 degrees plus 360 degrees times k. You can't subtract on this one because there is a letter there. These are unlike terms. Remember, guys, your algebra, you're also using the algebra concept, angles and angles on their own. K is a number, it's not an angle. K is an integer, just 1, 2, 3, minus 1, minus 2, 0, and so forth. Okay, so we need x, not 2x. So what do we do? Divide each and every term by 2. What is multiplying here, you divide by it throughout. So x is going to be, if we were to divide this by 2, each and every term, this was going to give us 86. That is 86.79 degrees plus 360 divided by 2, that is going to be 180 degrees times k. So this now we have x here. What we want is x. It's true that there was a 2x, but what you're solving, you don't solve for 2x plus 30 degrees. No. 2x plus 30 is the one that is given, but whatever that you're solving, you are solving x. Solve for x. You need to know what is x, not 2x plus 30, but what is x. That is why we are supposed to have our general solution. So this part is of the general solution. But remember that we are told that the x now is taken from minus 90 to positive 90 degrees. So if this x is being taken from minus 90 to positive 90 degrees. All right, so therefore we can conclude what is going to be our x from this general solution that we're given. So how do I find the exact solution? Because this is the general solution. It is the mother of all solutions. It carries all solutions are within this. That is called the general solution. It's the mother of solutions. So how do we move from there to the exact solution that is in within? Because it carries infinite solutions from minus infinite up to positive infinite. So we need exact ones which are in within the interval that we are given. So since this is an integer, I just have to try my values from k, because k is an integer. Remember, k is an integer that we are talking about. So you just try the k to be equal to 0, k to be equal to -1, k to be equal to -2, k to be equal to 1, k to, and so on. That is how you try. You just substitute these values because integers, positive or negative whole numbers, and 0 is also an integer. All right, so this is it. If you were to substitute here, I want you to see properly here, guys, so that we do not waste too much time. This is 86. Just put this on your calculator, comma, 79 plus 180 degrees. Open a bracket like this. This bracket is representing k. These are the integers that you're going to substitute. So if you are someone who are not used with numbers, we are different as we look into the numbers. Someone can tell that -2 cannot work, -1 cannot work, 0 is the right one. You can see that. So if you are not used, don't try bigger values. Just try from -2. Just put -2 here. -2. Okay? This is k here. What is the answer? Answer is giving us -273.21. It's a solution, this one, but only that it does not lie in within our interval. So we cannot take this one. We cannot take this solution, but it represents x. If you substitute this is a solution, but only it is not within our interval. So we move on from -2. We can't move on to -3 because it is becoming more. So we move on to -1. -2, -1. Okay. -1, we substitute. What are we having? -93.21. This is not within because we are supposed to start from -90 to +90. Between -90, it's -90, -89, minus, and so on. These are the numbers that we are talking about up to a condition where we reach a +90. So -93.21 cannot be there. You substitute a 0 this time. You used -2, -1. Let's substitute a 0 there in place of our k. So you're going to substitute a 0 like this. What are we having? 86.79, meaning to say where k is equal to 0, this can give us the exact solution because 86.79 is in within -90 to 90 degrees. It's in within these numbers. So this is our solution. So therefore, we can say our x from this is equal to 86.79 degrees. It's a solution, this one. Okay. If you move on to 1, by just looking, guys, this is a 1. If you add, it's a positive. Look, the numbers are already 180. It's already above 90 degrees. So it means there are no solutions. It's not going to give a solution, but you can even try. Just put a 1 here and see. Look what you're going to have. 266.79 is bigger than 90 degrees. If you substitute at 2, it's going to be worse. These values, they are becoming bigger and bigger and bigger. But they were actually solutions of this. These are x values, only that they are not within. If this interval here was from -360 degrees up to +360 degrees, it means all these solutions that we are talking about, this one, when this was equal to 1, it was supposed to be taken because 266.79 is within 360. Now it does not work because of the interval. So what limits your solution is the interval. If it was from -720 to 720, it means even when this was at a 2 like this, the 446 points, we're going to take it because it's within 720, below 720. So you work with the interval that you're given. So in this case, we are limited because of what? Our interval. They are saying from -90 to 90. So this is the x that we are going to take. All these ones, they are not going to work. All right. So this was a solution that we took from, remember, we are still, guys, remember, don't forget, we are working from where? The third quadrant. We are working from the third quadrant. That is where we solved this one. We still have to find the general solution from this side of the fourth quadrant. Remember, we created our general solution. We do the same thing we solve for x. That is how you answer these questions. So let us solve for x. Just like the previous case, this is going to be 2x plus 30 degrees is equal to, we subtract this part. This is going to give us 336.42 degrees plus 360 times k. So, okay, we can subtract this, transpose the 30 degrees. It only subtracts here. All right, be careful on that part. So it means we're going to have 2x 336.42 minus 30 degrees. So you subtract this. This is going to give us 306. That's 306.42 plus 360 degrees times k. All right, we need x, not 2x, not 2x, but x. So what do we do? Divide each and every term by 2. Up to the last part, we divide by 2. So that means x is equal to 153.21 degrees plus 180 degrees times k. So this is the final general solution that now you are going to test to find the exact value of x, which lies in within the interval that we are given from minus 90 degrees up to positive 90 degrees. Don't forget that interval that you're given. And k being an integer, you can substitute any of those values, just like the previous case. You're going to have our k start at 0 there, minus 1, minus, don't even, minus 2 can be even bigger, but just try that. K is equal to 1. By just looking 1, if you substitute a 1, it's already above 180. It's positive 153, positive 180. So these solutions, they're actually out. At k is equal to, if you substitute a 0 here, this is going to be a 0 plus 153 point. It's already above 90. So this is not going to work. At k is equal to 0, there is no solution there. All right, let me just bring the calculator and see and show you guys what I'm trying to say. This is now another part that you're considering. So you write this, you just present this on your calculator as it is 153.21, okay, plus 180 degrees into the bracket of, then this, like I said, at 0 there, there's no solution that you're going to have. 153, it's above 90 degrees. Also at 1, there's no solution there. It's greater than 90 degrees. So we move on to -1. Let's substitute when this is -1. At -1, our x is equal to minus 26.79, and this is within our solution because we need a negative between minus 90 to 90. So this can work. So meaning to say, where k is equal to 1, we are going to have our x as minus 26. That was minus 26.79 degrees. It's also part of our solution. At k is equal to -2, you can just try this one and see if this is -2. We're going to substitute k being -2. Let's see the answer. Answer is -206. It's out of the interval because our interval is supposed to start from -90 up to positive 90. So that is out of the interval. So this x is also part of our solution. So these are the exact, we're now talking about exact solutions now from the general solution. You write the exact solution. So there are two solutions which satisfy this interval that we are given. There are just two solutions that we are going to have. So therefore, we can conclude that our x is going to be negative 26.79, or our x is going to be given as 86.79 degrees. In within the interval that we are given, in within that interval that we are given, in within minus 90 degrees and 90 degrees, in within this interval, we are limited. It's a limit that you are given. So you have to answer this type of a question carefully. You have to answer this type of a question carefully, because there you are not answering up to the general solution. You have to obtain the exact solution. That is why you are given an interval to work from. That is why you are given to that interval. So the x values can be obtained from general solution, which is true. But do you know how to apply the general solution? That is the concept. So these are the typical questions that you might be given. So the first thing is that you determine the reference angle. The reference angle, you ignore the negative that you're given. That's if it was a cos, you determine arc cos of what you're given. If it is a tan, it's arc tan of what you're given. This was a sine, so it was going to be arc sine. Okay, then you determine the angle where this ratio is situated. The angle, the two angles. So this part here, these ones, they are going to be two. When sine is positive, when sine is positive, there are two positions, first and second. When sine is negative, there are two positions, third and fourth. So always, whether it's a tan, it's a cos, you are not going to have three different solutions to say there is a general solution here, a general solution, another general solution. It's impossible. They are going to be just two. Okay, they are just going to be two. Where tan is positive, there are just two positions, in the third and in the first. Where tan is negative, two positions only, the second and the fourth. So after determining, knowing where the trig is situated, you now move on to solving, presenting your general solution. For cos, you add 360 times k for cos and a sine. This is because of their period. They are taken at a period of 360. But for a tan, 180 degrees. That is the consideration. So I hope you are going to use the same idea to answer different questions that you might be given in a future case. All right, this is 6.3, which is to determine the general solution of this. So this time you're just determining the general solution. There is no solving for x. That is why you are not given here an interval to say your x is going to be taken from a certain value to a certain. That is why you're not given that. Remember, I said the general solution is the mother of all solutions. It carries all solutions. That's the general solution. So that's why we are not given an interval there. We just need to present it. It is the mother of all solutions. It's not limited from here, from this value to this. No. The exact solutions, when we need x, that is those ones, we have to specify from this to this value. All right, anyways, let's check. The 6.3, we need to determine the general solution. 3 sine of x times the cosine of x minus 4 cos squared x is equal to 0. 6 marks for that. So on a typical question like this one, where you can figure out that there is like sine cos, then there's a cos there. There's something that we are seeing. Factorization can play around. It's just like you're given 3xy minus y squared. You can factor out the y because it is common. It's just like our algebra. So the cos of x and the cos of x is common. So we can just factor out the cos of x. Remember, to factor out, we divide this divided to the cos of x. It cancels. So we remain with the 3 sine of x. So 3 sine of x minus, this is minus 4 cos squared. If you divide by 1 cos there, it means we're going to cancel this. That will be 4 cos of x. Okay, this is equal to 0. This is what you have, and this is equal to a 0. Now, from the 0 concept, we do understand the product of the two to be equal to 0. It means one of these must be equal to 0. The product of these two to be equal to 0, it means one of these must be equal to 0. So that means it's either the cosine of x is equal to 0. The principle does not change because it's a trig. No, still same principles. So we still have that 3 minus sine x, 3 sine x minus 4, the cosine of x is equal to 0. So here there is nothing that I can do. Just leave it like that. You determine your general solutions from there. It's fine like that. You are going to see that in most cases, you guys, you are tempted to divide this because you see that cos is the same, and you are tempted, even here, you are even tempted to divide by cos of x because you say this will cancel and this I have a 0. No, never be tempted to do something like that. By doing so, you have removed other solutions that were supposed to be part of your answer. It is just like in your algebra. If you are given x into the bracket of x plus 2 is equal to 0, you don't divide by x because x is out of the bracket. You divide, so you say x plus 2 is equal to 0. No, you don't do that. The same way that you're solving your algebraic expression to say either this is equal to 0 or this is equal to 0 is the same concept. The same part that we had, even if it was before, if this is y squared plus y is equal to 0, you don't divide by y because there's a y and a y. You have to factor out. Same, just like our algebra. But now this is trigonometry, guys. We are limited to some principles also, identities which are supposed to be applied. On a situation like this, whenever you see a sine and a cos, be careful. Whenever you see this, a sine and a cos on the same equation, think of an identity, think of the ratios there, think of your identities, think of this tan, because there's something about this tan. The tan is equal to the sine of x over the cosine of x. So whenever you see a sine and a cos on a single equation, think of this. But in order for us to have a sine and a cos, it means one must be on the other side of the equation. One must be on the other side of the equation. So I cannot have a tan when it is like this, or I cannot have a sine over a cos because it's going to affect the other part. So what do? I just have to transpose this way. 3, I can transpose this, 4 cos to the right-hand side so that it becomes a positive. So it's going to be the 3 sine of x is equal to 4 cos x. It was a negative, it becomes a positive. Remember, we want a tan, which we know is sine over cos. So to obtain sine over a cos, it means we have divided by cos. So we are going to divide by cos to achieve what we want. So this is going to cancel, meaning to say we are left with a 4 here. But on this side, we have achieved exactly what we want. Sine over a cos. What is the equivalent of this? Sine over a cos. Sine over a cos is a tan. So that's 3 tan x. Sine over a cos, that's a tan. So it's 3 tan x, which is equal to 4. We want tan, so we divide by 3. So that's the tan of x is equal to 4 over 3. All right, so this is it now. You now have a single trig here and also a single trig. The general solutions, you don't just act sine or act tan or this. No, you must have a single trig, a tan, a cos, a sine. As long it's a single trig that you have there. So this is it. On a cos, we were supposed, this is a 0 there. So you're supposed to have the reference angle. In that case, the reference angle is arc cos of a 0. 0 now is just a neutral number. So arc cos of 0 is 90 degrees. On a cos, it's in most cases, you are limited or you are tempted in a way that you can even leave out some of the exact solution. The cos being a 0, it's a neutral number. You can't say it's a negative. You can't say it's a positive. So either way that you are going to have, you are still going to see that your answers are going to be exactly the same because 0 is a neutral number. So if you were to consider to say in which quadrant, because remember I said we need the exact angle now that you're going to use on the general solutions to say our x is going to be, is it 180 degrees plus the reference angle or what? In which quadrant do we have our cos being a positive, being a negative? Because it's a zero, it's a neutral. So are you seeing what I'm trying to say? So you'll be stuck to say which one. Just use whatever that you want for a cos. You still have the same answers, all right? So if you use the cast concept, you are going to see that if you had to consider cos being a positive, it's positive in the first quadrant. So we are going to take our x as the reference angle. There's no change in the first quadrant. If you consider in the fourth quadrant as cos being positive, it was going to be x being 360 minus the reference angle, which is 360 minus 90 degrees. 360 minus 90 degrees is going to give us 270 degrees. All right, so I want you to see that. You're going to have 270. Let's say you are considering as negative angles. You're going to say, okay, 0 is a negative because 0 is a neutral number. So you take it as a negative. You move on to this one. The solution was supposed to be 180 degrees minus the reference angle. So if you subtract 180 minus 90 degrees, what do you get? 90 degrees. Still, you move on to that 90 degrees. Back to that same answer. You move on to the tan where you are saying it's a negative. In the third quadrant, our x is supposed to be equal to 180 degrees plus the reference angle. So 180 degrees plus 90 degrees, you get what? 270. Still, you get the same answers as you were considering it as a positive. Why? As 0 is a neutral number. So this is how you deal with a cos. So in actual sense, you can just, when it is a condition that is a 0 there and we've got a 90, you can just write your solutions as plus or minus 90 degrees plus 360 degrees times k, if you want that. Or this is, if you are used it to the exact way, because you're supposed to have two solutions. The first one we said is going to be equal to the reference angle, which is 90 degrees plus 360 degrees times what? Times k, where k is an element of all the integers. The second one that you're going to have is when it is a positive in the fourth quadrant, 360 minus the reference angle. So it means when you subtract 360 minus 90 degrees, it is going to give us 270 degrees plus 360 times what? Times k. So this one, it was just equal to the reference angle. Then this one is going to be 360 minus reference angle, or you use 180 plus reference angle because 0 is a neutral number. So meaning to say these were the solutions that we're supposed to have in each and every condition that we are talking about. Our k is supposed to be an integer. So this is for a cos where we are dealing with a 0. For a tan, if you are to consider, you are going to have the same concept. So for a tan, we need the reference angle, just like what we had from a cos. So the reference angle is simply this one. It's a positive, so there's no like we have interchanged anything there. It's just going to remain as it is, which is arctan 4/3. All right, so if you're to simplify arctan 4/3 properly on your calculator, this was going to give you 53.13 degrees. So this is the idea now where tan x is what? Is a positive. This number here is a positive. So where tan is a positive, we know that tan is going to be positive and the, all right, let's just write cast. So it's going to be first and second. So in the first quadrant, it is as it is. All right, in the first quadrant, we saw that x is just going to be equal to the reference angle. So in the first quadrant, it means our x is going to be equal to the reference angle as it is 53.13 degrees plus, because of the tan now, because of its interval, because now we consider to say the period that is going to affect, it's at 180. So it's going to be 180 degrees times k this time. All right, then the other part, we said a tan being positive in the third quadrant, and we saw that in the third quadrant, it's 180 plus what? 180 plus the reference angle. So it means you can also consider that. This is the math of all solutions that we have. Where is it that a tan is positive? Where is it? Where this tan is a positive, you have to consider that. So tan is also positive in the third quadrant, which is 180 plus what? Plus the reference angle. So meaning to say, you can also consider that. So our x, you can also consider that to be something like 233, 233,13, like this, plus 180 degrees times what times k. Remember I said it is the mother of all solutions. It carries all the given solutions that you're going to have. So this is going to give us any solution that you're going to have within that interval. So these are not exact solutions. These are general solutions, the mother solutions, where all solutions are going to be taken from, where all solutions can be determined, or we can have those solutions now when they are now giving us exact intervals, they are going to be taken here. So there is nothing there. There is actually nothing. You just need to understand that trigonometry, when working with trigonometry, you need to know also your basics of your equations, because that is why we call trigonometric equations. There is a part of your normal equations that you also need to put into consideration before you think about what is it that we talk about, the quadrant, this and that. The solving of equations, the zero concept. Then you bring out your identities, your trigonometric ratios into play. You're going to see that you can answer any question on your trigonometry.